had quite a bit of success, quite a bit of failure machining metal on the wood lathe. These are the parts that I've made. I've had lots that are failures, but these were mostly successful. From left to right, this is kind of my progression of how I design parts and redesign parts. The part that's changed the most is the tip. I started out in brass. It turns out that when brass touches the eraser, it turns it all dark. I thought that was just oil and dirt from the machining process getting on the eraser. It turns out the brass itself actually turns this dark. So does silver and so does aluminum, unless it's anodized. So I need something that's either stainless steel or titanium, or two of the metals that don't do that. And that's what I went to next. I tried making in stainless steel. I realized that I wasn't quite sure of what my dimensions should be at this point, and this one ended up being a failure. So I went back to brass. Brass is easier to machine. I figured out my dimensions, got this one to work, and then I made a final one in titanium. The titanium takes a lot longer to machine, and it burns up my drill bits. This thing probably took me 9 hours to make. So this thing taking maybe 4 hours to make, still way longer than it would on a metal lathe, but it's good to get the dimensions figured out before I go to titanium. My original design models a drafting mechanical pencil, whereas this is a simpler design. I like them both. I'll probably make both in the future. Another component that's changed a lot is the clutch. This is the part that holds the eraser. This is the original one that I made by laser welding two tubes together. It's too stiff, so I decided to make the walls thinner. When I was machining on the lathe, that gave me more flexibility to choose whatever wall thickness I wanted. This one turned out alright, but it was too thin and the back part fell apart. I tried two more. These also ended up falling apart. Maybe make it a little thicker. This one turned out alright. Wall was a little thicker, everything worked. I tried making the groove a little wider so that these wouldn't be so stiff. They're about the right amount of stiffness, but I didn't like the grooves being so wide. This is my most successful clutch. It has long, thin grooves. It doesn't take very much pressure to push these inwards. That's important because the less pressure this takes, the lighter this spring can be. If it's a heavy spring, when you press to advance the eraser, it's not very pleasant to use. So that feels better when it's light here and a light spring. Additionally, this has this larger groove. This protruding ring is important because it interacts with the ledge inside of the threaded coupler. That means that the eraser mechanism can't slide back any further at some point. It has a positive stop here. I didn't have an issue with the eraser sliding inside the clutch, but one thing that I found was the spring compresses at a certain amount and the eraser won't slide. But if you push on everything, this ring moves forward. You can see it moves forward there. This protruding ring just prevents that from going back too far. It feels like the eraser is sliding back, but it really isn't. This makes everything feel a little bit better. One thing I do to prevent the eraser from sliding back in this mechanism is adding grooves on the inside. You can see the grooves here are just threads. The easiest way I found to add those grooves is to use a tap and add threads on the inside. That means it gets extra grip on the eraser. Another important component is this clutch ring. This is the ring that's pressed forward by the spring, and when it is, it closes up the clutch that holds onto the eraser. I originally thought that the inside needed to be tapered to match the taper of the clutch. It's important that it's held here by friction, but that taper made things worse off for me, so I realized no taper on the inside is better than having a taper. I'll show you on a mechanical pencil to show you what I mean. The mechanical pencil functions the same as a mechanical eraser. When you first press the button, everything moves together. The clutch is holding onto the lead. If you push the clutch far enough, this clutch ring will be pushed back. That will allow the clutch to open and it will no longer influence the lead. The lead is held at the tip here with a little bit of friction. When this clutch moves back, it piles onto this part here and compresses the clutch again. Again, the clutch holds onto the lead until it's pushed forward far enough for this ring to be moved back. It's important for this ring to hold onto the clutch for this amount of travel because that's how far the lead moves out. That amount of space here before the clutch ring is pushed back is how far the lead advances. That's why it's important for this clutch compression ring to be held here with friction. If this falls back too soon, it won't advance the eraser. A major improvement I made to the clutch was start out with brass and went to stainless steel. The brass turned the eraser dark and the stainless steel doesn't do that. Started out with brass 290 3/4 hard and I went to 304 stainless steel that's annealed. Thread coupler has also had a few improvements. This is the part that holds both pieces together. Like this. I realized there was an issue with this though. With any thread, there's going to be play. When I made this, I screwed them together and filed everything smooth. The issue I ran into, because both of these are onto a thread and they reference only against each other and that thread, they don't go together the same way. It's hard to show here on camera, but there's a small sharp groove. If I add a lip that both parts can reference to, that means they'll come together the same way every time. That makes manufacturing harder because I have to thread from this direction and thread from this direction when I'm making it on the wood lathe. Having these two pieces come together onto this lip helps them come together the same way every time. It also makes sure they're straight. Otherwise they tend to bend a little bit one way or another. So everything with this design is straighter and it also comes together. So I can file this all smooth and you won't be able to hardly see the gap. This thread coupler is made out of titanium. It doesn't work though because when I flipped it around to hold it, I ended up crushing it. I held it in this 3-jaw chuck. When you tighten this down, I added too much force. I need force because this is the tool I use to add the threads. Come from this direction and add the threads. This die goes over the top. It takes a lot of force, so that means I need to crank down on this to hold it. The titanium's strong, but it wasn't strong enough to withstand this process. So it's hard to make, a lot harder than this one. So I could just hold it back here and thread all the way over the top. I didn't need to worry about flipping around and holding it by this thin part. I've had a lot of issues with these thread couplers. Sometimes I end up crushing them, and other times my die isn't very good and it doesn't make good threads, so things don't thread together after I'm done. I started out with this thin aluminum thread coupler. I made it stronger by changing my dimensions a little bit. I also added that lip on the inside, which means that this mechanism doesn't slide back. You can see it slides all the way through this one. I then made it in stainless steel so it was a little stronger and the threads were a little bit better, and then I tried that titanium one that didn't work out. Not much has changed with the bodies. Here's one in aluminum. This is straight line carbon fiber. This one's woven carbon fiber. This one's flame anodized titanium. This one's just plain titanium. They're pretty simple to make. They usually work out. Sometimes the threads don't work out on the inside, but overall these have been a success. Not much has changed with the button on top. They're pretty easy to make. These two are made in brass. This one has a cubic zirconia set in it. And this one's made in titanium. I ended up getting this cool pattern on top, which I like quite a bit. It was accidental, but I like it a lot. For the internal tube, not much has changed. I changed it from this brass tube to this stainless steel tube. That gave me more space for the mechanism down by the clutch, and it also made things a little bit lighter weight. Lighter weight means that the balance is further towards the tip. This is what I was able to make on the wood lathe. This is a full titanium mechanical eraser. It works as you would expect. When you click it out, the eraser does not slide back in, no matter how hard you press. I've been using this for a few months now, and I've been happy with the results. Like I mentioned, I still need to make that thread coupler better. I'd like to make this clutch a little stronger too. Other than that, I'm almost there.